Algebra 2, this is Unit 6, Day 4, solving radical equations. The first question we have up here, it says, how do you solve for x in the following equations? So if you look at equation 1 and 2, they both have an x squared, and the whole idea is to find x, right? So first you want to isolate the x squared. And then once x squared is isolated, you're going to take the square root of both sides. Then you're going to solve. Then you're going to check. So let's follow these steps when we solve equation number 1. 3x squared plus 10 equals 37. So we're going to isolate the x squared. So you're going to subtract 10 first from both sides. Now we have 3x squared equals 27. Divide both sides by 3. Now you have x squared equals 9. X squared is isolated, so now we're going to take the square root of both sides. Take the square root of x squared, which is x. Take the square root of 9, which is 3. X equals 3. Plug it back into the original. 3 times 3 squared is 27. 27 plus 10 equals 37. So that checked out. Go ahead and try equation number 2 on your own if you want, or you can just follow along with me. We're going to, again, isolate x squared, so we're going to add 16 to both sides. Now we have 1/4 x squared equals 50. Now we're going to multiply both sides by 4 over 1, or 4. That isolates x squared. We get x squared equals 200. Take the square root of both sides. We get x equals, square root of 200 can be simplified, as you know from previous dates. So that's going to be the square root of 200 would be the square root of 10 times 10 times 2. Circle root of 10, and you get 10 radical 2. Okay, if you plug in 10 radical 2, that should also check out. So as you'll see in later examples, it's very important to check your work because we're going to learn about extraneous solutions. We'll talk about that later. But how are squaring and square rooting related to each other? The best way to say it is that they are inverse operations of one another. Just like subtraction and addition are inverse operations, or multiplication and division are inverse operations of another, squaring and square rooting are inverses of each other. So, for instance, what is an example of what this looks like? Okay, 4 squared is equal to 16. Okay, well, what's the square root of 16? It's equal to 4. Okay, so just let that sink in there real quick. Or you could look at it this way. What's the square root of 4 squared? It's equal to 4. All right? 4 squared and 16 are the same thing. So take your pick. The square root of 16 equals 4, or the square root of 4 squared equals 4. Hopefully that helps you understand how squaring and square rooting are related to each other. So now, using your ability to isolate terms and perform the opposite operation, solve the following for the given variable. We have negative 12 equals negative 6 times the square root of b plus 4. Okay, so we want to solve for b. As you notice, it's inside the radical here. So what you have to do first is isolate the radical. Okay, so you're going to isolate the radical first. And I added the steps over here to the left for your convenience. So first we're isolating the radical. In this case, we're going to divide both sides by -6. Since that was multiplying the radical, we're going to divide by -6. So that cancels out on that side. -12 divided by -6 is +2. And now we have the square root of b plus 4. Okay? So since we're taking the square root of b plus 4, the opposite of taking the square root of that would be to square it. So we're going to square both sides so that we can get to that b. Okay, so now 2 squared is 4, and 4 is going to be equal to b plus 4. Okay, if you're still having trouble seeing why they cancel each other out, imagine the index there would be 2, right? So when you do that, the exponent cancels out the radical, okay? Similarly, say you had the cube root of something, and you were, trying to solve a similar equation, you would have to cube both sides, and you'll see an example of that later too. But let's go back to 4 equals b plus 4, and go ahead and solve that. Subtract 4 from both sides. You get 0 equals b. Okay. So now that we've solved, we need to check in the original problem. So make sure you do that. Go ahead and plug in 0 for b and make sure that it works. As you can see, when 0 is used for b, you get a true statement, so your answer checks out. 0 equals b is the solution. So here we have some practice problems. We have the square root of 3n plus 12 equals the square root of n plus 8. As you notice, we have radicals on both sides of the equation, and our variable's n. That's also underneath both radicals. So we want to find out what n is, and in order to do that, we need to square both sides. Okay? So squaring the square root will undo that. It's going to leave us with 3n plus 12 equals n plus 8. And now it's going to allow us to solve for n. Okay, so we're going to subtract n from both sides. Now you're left with 2n plus 12 equals 8. Now subtract 12 from both sides. You get 2n equals -4. Divide by 2, and you get n equals -2. Now make sure that you check in your equation that you put -2 in place of n and get a true statement. So we're going to go to the original problem and check our work. So I'm going to go ahead and do that. You guys do that on your own, and then come back and check to see what I got. So go ahead and hit pause, do the check, and come back. So if you check correctly, you get the square root of 6 equals the square root of 6. That's a true statement. So we can go ahead and say that n equals -2 is our solution. All right, and have I said yet that it's important to check? Yeah, I know I've said it a bunch of times, and here in example number 3, we're going to find out why. So without giving too much away, just be sure that you check your answers at the end of the problem, okay? So checking is as important as any step. Here we have the square root of x plus 12 equals x. So you guys are getting familiar with this. We want to get rid of this radical, so we're going to square both sides. Okay, here we have x plus 12 equals x squared. All right, going back to the beginning, we're solving for x when we have an x squared. Now think about it, when you have an x squared, you realize it's a quadratic now. We can solve this by setting it equal to 0 and factoring it. So that's what I'm going to do here. I have x squared over on the right, and now I'm going to subtract x from both sides, and I'm going to subtract 12 from both sides. We're going to get 0 over here on the left, and now we're going to have x squared minus x minus 12. Okay. If you need to see that again, you can go ahead and rewind. And now what we're going to do is, since we have 0 equals x squared minus x minus 12, I'm going to factor that. It's a trinomial where a is 1, so that's going to be x minus 4 times x plus 3. because negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. So now that it's factored, we're going to set both factors equal to 0 and solve. So we say x minus 4 equals 0. Solve for x. We get x equals 4. And then we're going to set our other factor, x plus 3 equals 0. Solve that. Subtract 3, and you get x equals negative 3. All right, so yeah, remember we're going to check in the original problem. Okay, so let's try 4 first. I'm going to put the 4 in there and let's see what we get. As you can see, when you check x equals 4, you get a true statement. You end up with the square root of 16, which is equal to 4. That's great. Now we're going to put negative 3 in for x. So go ahead and check with negative 3 in place of x, and let's see what happens. So when using negative 3 for x, you should have gotten the square root of 9 equals negative 3. Okay, so when we're doing this, we only accept the positive. So the square root of 9 is equal to positive 3, not negative 3. Okay, so in this case, it's a false statement for when x equals negative 3. X equals 4, that's a legitimate solution, but x equals negative 3 is not. So we call x equals negative 3 an extraneous solution. We're going to keep x equals 4, and x equals negative 3 is extraneous. Okay? So extraneous. Extraneous. Okay? So remember that and what it means. X equals 4 is a solution. X equals negative 3 is an extraneous solution. So ask yourself why that is, and if it still doesn't make sense, ask us in class. All right? Now try number 4 on your own and be sure to check. I'm going to go ahead and solve it. If you're still not comfortable with solving them on your own, you can follow along. But at this point, you should be okay to try it on your own at least and see how you do. Then compare your answer to mine. So you can go ahead and hit pause, and I'm going to put my work up on the board. So you got x equals 1. But did you remember to check your work? So now go ahead and plug in 1 to your original equation and let's see what happens. So as you can see, after checking, you get the statement 6 equals 2, which is false. So x equals 1 is an extraneous solution. So we'll say extraneous. All right, as you can see at the bottom of your notes, it says, how can you relate this to real life? So we're going to go ahead and say, see the meteor example above. And then we can also answer that question, how can you check your work? You can check your work by plugging your answer into the original equation, and of course, be on the lookout for extraneous solutions. All right? So make sure your solutions work. If not, they are extraneous. All right, so let's do this real world problem, and that should be it for our notes today. So we have, for meteor crater in Arizona, the formula d equals 2 times the cube root of v over 0.3 relates the diameter d of the rim in meters to the volume v in cubic meters. What is the volume of meteor crater if its diameter is 1,200 meters? So the diameter d is 1,200 meters. In my equation, I'm going to replace d with 1,200. Now we're going to use what we've learned to find the volume of the crater. Okay? So v is the volume. That's what we're looking for. First, we're going to isolate the radical. So we're going to divide by 2 on both sides. That gives us 6. So now we have 600 cubed is 216 million, and that's equal to v divided by 0.3. So we can make 216 million a fraction by putting that over 1, and now we can solve by cross multiplying. V times 1 is v, and 216 million times 0.3, 64,800,000. So our answer is 64,800,000 cubic meters. That's it, and have a great night.